3, theoretical and experimental probability. I can calculate theoretical probability and experimental probability.
Very smooth, Rosh. You have the voice of like a radio announcer. Nice job. Well done. All right, Bergen, what's a trial?
Trying or testing a certain amount of time.
Yeah, trying or testing something a certain amount of time. So if I were to flip a coin 20 times, how many trials would that be? 20. Theoretical probability. You guys should know this one because it's the same as probability. It is the number of favorable outcomes over the number of... What does favorable mean, Cicero?
What should happen?
Favorable means what should happen?
Favorable is the same as...
No, favorable is, Jocelyn?
What you want to happen.
What we're looking to have happen. Not what we want, what we're looking to have happen. Okay, and then experimental probability on the count of 3. I would like you guys all to recite that formula because it's a new formula. 1, 2, 3. So the number of times something happens or an event occurs over the number of times you do it or the number of trials. Another name for experimental probability is what, you guys? Relative frequency. What is the relative frequency of something happening? And then the last thing is the official definition, or our official definition is theoretical probability is what should happen. Experimental probability is
What did happen?
So in order for experimental probability to exist, you have to do something, right? All right, so number 4 was just an example of theoretical probability. We had a spinner. I asked you for some calculations, and you told me them. I'm going to move on. Number 5, we did some experimental probability, right? And if you look at all the data down here, it shows for Emma's group how many times she rolled a 2 and the number of trials, right? And Jocelyn's group, how many times did she roll a 2 and the number of trials? Jake's group, how many times they rolled a 2 and the number of trials, and so on and so forth. So the entire class did this, yes, no?
Yes.
And then we went all the way down here and we said, or we asked, well, that's great, but what is the theoretical probability of rolling a 2? Before we even do the experiment, what should happen? What should happen? We should get a 2, 1 out of every how many times?
6.
Huh? Is everybody out there?
Mm-hmm.
Jocelyn, you here with me? 1 out of 6, and what is that decimal? 1700ths. So if you look at all of the results then, did everybody get 1700ths?
No.
They were all over the place, weren't they? So what we did then, in order to get these decimals, is we converted our fractions to decimals, yes, no? Because a fraction is what kind of problem? It's a what? It's a division problem. And we found out which group was actually the closest. Jake and Swara. And then we actually, instead of rounding to the nearest hundredth, we went to the nearest thousandth. And we found that actually the closest group was by 2/1000ths of a percentage, right? 2/1000ths of a decimal, or 2/1000ths, period. And then in the very, very end, you guys, this was fun. We took all of the times we rolled a 2 as an entire class. So as an entire class, how many times did we roll a 2? And how many trials did we do? So we took 58 and we divided by 335, and what did we get?
17.
So 1700ths, and what was the theoretical probability of rolling a 2 again? What?
17.
I just went right by it. It was 1700ths. So our experimental probability actually matched our theoretical probability. Yes or no?
Yes.
Is that like magic? I think it is.